Welcome to our presentation on climate change and its global impact.
We looked at climate change because of its presence as a global issue. We wanted to see how rising temperatures affected different areas of the planet and society. The 5 areas we focused on were ocean level rise, gross domestic product, disastrous weather, Arctic ice concentration, and crop yields. From these areas, we found which was most impacted using the linear correlation coefficient for each variable versus the rising air temperatures. The first area we looked at was ocean level rise because this is a very common topic in conjunction with global warming. The 2 more varying scatterplots showed the change in air and water temperatures over time. They both show the same trends as time goes on, being fairly flat from 1880 to about 1940 with a large spike and then a continuous upward trend. This is mirrored in the ocean level rise graph where it is fairly linear from about 1880 to 1940 again, and then becomes more parabolic as time goes on. This shows a very strong trend between the rise in air temperatures and the rise in sea levels, and it has a linear correlation coefficient of 0.863.
All right. In our analysis on economic growth relative to climate change, we felt it was an important question to ask because it allowed us to look at a potential cause of climate change. We began by constructing visualizations that showed that temperature is indeed rising for every country over time. And then we moved on to our analysis of GDP per capita relative to climate change. Next slide. In this analysis, we have 3 visualizations. The first one is a line plot that shows that for each country, as mean GDP per capita increases over time, so does mean temperature. This is supported by visualization 2, which is the same data represented in 2-dimensional binning, so that you can more clearly see the positive correlation between the variables. The third visualization is a scatter plot where each point represents a country, and it maps the net change in GDP per capita relative to the net change in temperature between 1800 and 2013. This graph displays that countries with higher net changes in GDP also have higher net changes in temperature, whereas countries with lower net changes in GDP have lower changes in temperature. This supports the conclusion that there exists a trade-off for nations experiencing higher economic growth. Their temperatures are rising at levels higher than their less economically developed counterparts.
Natural disasters are critical to understanding the impact of climate change. We found that as temperatures increase, natural disaster frequency, cost, and death count all increase. Specifically, the correlation between disaster frequency and temperature was 0.45. Next slide. Splitting by disaster type, we found that disaster frequency was stable or increasing for each disaster. However, disaster cost and death count increased only for those disaster types that were most likely with higher temperatures.
We also thought it was important to explore the melting of polar ice caps using the NOAA Sea Ice Extent dataset, which contains monthly data on ice concentration as a percentage. An unusual pattern that can be seen in the upper right graph is that Arctic ice concentration actually increased a little after 1950. This is consistent with a carbon dioxide decline in the 50s, which in turn caused rises in ice concentration later on. The delay of the effect can most likely be attributed to water's high specific heat. As seen in the bottom left graph, an overall negative relationship between Arctic ice concentration and temperature is evident, but it does not seem to be linear. The correlation coefficient was determined to be moderate with a value of negative 0.601.
The final area of analysis is determining if global warming plays any role in the ability to grow and harvest food. To do this, we took the top 10 grown crops globally and analyzed them against the temperature data for each year. And in doing so, we found that crop yields tend to be higher when temperature increases. Across all the top 10 crops, the correlation between these 2 data points was 0.715, which is fairly strong and tended to look like the graph you see on the left side of your screen with soybeans. However, there is an outlier with sweet potatoes on your right being the only crop that we analyzed that actually decreased over that time period. And we go ahead now and conclude and sum up our results. We found that an increase in GDP actually increases temperature. And this increase in temperature leads to a few effects. First off, ocean levels tend to increase, which can be a negative. Temperature and crop production actually increases, which is actually a positive. Total ice concentration decreases and disastrous weather does increase. And so what's important to note is that the majority of our findings actually represent some of the data that has been found externally through other data projects. But there's one outlier here, and that's temperature and crop production has actually been found in external studies. Temperature has been found to decrease crop production. And we have some ideas why there's some deviation here, but unfortunately, due to the time of the presentation, we can't go into that now. But obviously, if you have any questions, please feel free to let us know. Thank you so much for listening to us, and we hope you found this informative.